All right, so back to the proof. We have angle 1 congruent to angle 4. We're trying to prove that triangle ABC is isosceles. Definition of isosceles is that two sides are congruent. So really, if our last step is going to say triangle ABC is isosceles, probably the step right before it needs to say what? Jess? Yep, that's good. BA. Perfect. Right? If we could get those two sides congruent, then this would be an isosceles triangle. All right, so let's go backwards from there. In order to say that BA is congruent to BC, what might we be able to say before that? If only we could get what? Then we could say the sides are congruent. Yeah, Joe. So if I say the triangle adds up to 180, then I'm going to be able to say that BA is congruent to BC? Okay, but how are the angles adding up to 180 helping me know that two sides are congruent? I mean, you're right that we're going to need that somewhere, but I want the step right before this. Nope, right before this. What have we learned that says, if this is true, then BA must be congruent to BC? If we could say angle 2 is congruent to angle 3, then we can say, then BA must be congruent to BC. What would be the reason? If the angles are congruent, then the sides are congruent. What's the reason? Good job. Converse of isosceles triangle theorem. Right? And then, okay, sides are congruent, therefore it's an isosceles triangle. What would that reason be? Yep, definition of isosceles. All right, so we're really down to this problem. How could we get angle 2 congruent to angle 3? That's what we have to figure out. How could we get angle 2 congruent to angle 3, knowing that 1 is congruent to 4? They are linear pairs, exactly. So we might start, I'm going to do a 2-column proof for starters. Those of you in 22, I'm going to have to readjust to what your proof would look like. But we're going to start with the given, angle 1 congruent to angle 4. Now, angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4. What allows me to say that? Yep, linear pair postulate. Well, if 1 is supplementary to 2, and 3 is supplementary to 4, and we know 1 and 4 are congruent, yep, then we could go straight to this. 2 is congruent to 3 by congruent supplements theorem. And then we're done, right? Yep. Question? If you're trying to say that the triangle is isosceles, most likely you're going to get the angles congruent, and then you have to say the sides are congruent by converse. And then since the sides are congruent, then it's isosceles by definition. I mean, if you already know the sides are congruent, then you're just going to say it's isosceles because the sides are congruent definition, right? So if you usually you need the angles first. Yeah. Okay. Okay. Converse is when you know the angles are congruent and you're stating therefore the sides are congruent. That's converse. because the theorem itself starts with, okay, thank you. The theorem starts with sides congruent, therefore angles congruent. That's the regular theorem. So converse, yeah. Honestly, if you just have isosceles triangle theorem, you probably won't lose. Okay, good. All right, so we'll do this other proof here. Those of you who are in 22s, want me to put that in a flow chart, right? You would just put a box and that would go under it. It would lead to, actually this would be separate, like under there. And then they would come together. Underneath, yeah. All right, so this one, F and H are complementary. I'm going to do this one as a flow chart. You guys are going to have to adjust this one, okay? All right, so angle F and angle H are complementary. That's given. So for you guys, this is statement, reason, okay? We're trying to prove that triangle FGH is a right triangle. What does it mean to be a right triangle? One of the angles has to be a right angle. So one of the angles has to equal 90 degrees, right? Okay, so if we know that F and H are complementary, what does that tell us? They add up to 90 degrees. So since that's directly a result from this given, we're going to put our arrow here. What's the reason? Yep. All right, so let's think through the logic. Logically speaking, if these two add up to 90, what's the measure of angle G going to be? 90, which is going to make it a right angle, which is going to make it a right triangle. How did you know that that was going to be 90? So all the angles have to add up to 180. So that's the general statement that you're going to make. For 22s, you're going to make that here. Measure of angle F plus measure of angle H plus measure of angle G equals 180. Right? That could go the very next step in a two-column proof. What's the reason? Yep, triangle sum. Right? Sum means add them up. Right? Triangle sum theorem. Well, if the measure of angle F plus measure of angle H is 90, I can now combine this and this and take out the F plus H and replace it with what F plus H is equal to. In other words, 90. So 90 plus the measure of angle G equals 180. And what's that reason? Alexis, what do you think? What's that reason? I took this equation, F plus H, I kicked that out, and I replaced it with what F plus H is equal to. What's that mean when I kick one out? Yep, we're substituting. Substitution. So from here, I can just solve for measure of angle G by subtracting. And then you say angle G is a right angle. Definition of right angle. And then you can end with triangle FGH is a right triangle. Reason, definition of right triangle. Definition of right angle. So here it's definition of right angle because the right angle is that it's 90 degrees. Here, definition of right triangle because definition of right triangle says that it has a right angle in it. All right, you guys can adjust to this 2 column, right? It's just basically the same.